Okay, so I know that it's really hard to be on the last talk because there is a cocktail coming, and I assume some of you have already started. So I'll try to, yeah, not drag this presentation for too long. Also, there is another thing. I changed a little bit the title of this presentation because initially the title was a little bit more clickbaity. So it was the 5 quality metrics you ever need. You won't believe what number 3 is. So I changed it, and now it's measuring quality. But it was a little bit late too because they already printed the program and stuff. So measuring quality. Okay, where we are. All right, so is it even possible to measure quality? This is something that we can't touch. We cannot put on the scale to measure it. There's no height, there's no width, there's no volume. So it's really hard to argue about that. Do we even try and do that? There are some companies that actually try and do that, but there's other companies who seems to, as if they don't care. For example, Facebook. Facebook is one of those examples where when you're a monopoly, you know, and if there are defects, what are you going to do? You're going to post on MySpace? I don't know, for those of you who know what MySpace is. I'm showing my age because I know what MySpace is. Also, quality means different things to different people. For the CTO, it's one thing. For CEO, another. For the QAs, another. For developers, something else. For the PMs, something else. So how can you, I don't know, combine all of this to have a concrete measure? Well, so I think I can help you with that, and I think I know how this can be done. If you remember only one thing from this presentation, is this. So ask yourself this question. We actually did it ourselves. If the quality of our product improves, what would we observe? Okay, so there has to be something measurable. When a quality changes, it can either become good or bad. So something has to change. So if you focus on those areas, then it's not that hard to measure that. And so we said, okay, so what would we observe if you have better quality? Do we have more unit tests written? Okay, maybe better quality may mean more test cases executed or more high code coverage, so 100% code coverage. Maybe do we have more defects found before release? The term I think is escape defects or something like that. Well, all of those things are outputs, and all of those things are the effort that we put into the product, but it's not necessarily will lead to the same. So you put something, but it does not necessarily mean that you get something out of it. So for us, at least, those things we don't pay much attention to those because it's the effort. It's not the effort that we put; it's what the outcome is. So the idea is to measure outcomes, and we measure 5 things to figure out. 5 things to figure out what the quality is. Okay, first one is customer complaints. So we argue that if the quality gets better, we should have less customer complaints. Okay, so it's simple enough. So the way it works with us is we have a phone call or maybe an email. Customers pick up the phone and give us the middle finger and said, hey, this is not working, and I'm firing you or whatever. So so number one thing is customer complaints. So let's look at some of the data here. These are the number of weeks, the beginning of 2019. So the first week of the year, second, third, and so forth. Okay, and we put the numbers, how many customers complaints we get each week. Okay, so 39, 42. In this format, in the table format, is not very meaningful. Okay, so then we said, okay, well, let's see change between weeks. Okay, so as you can see, there are some changes where some weeks where there is no change, so 0% compared to the previous week. Green means improvement. Orange means it's getting worse. The first week of the year, we have 279 percent more complaints. So if you look only at those numbers without knowing the context, you say, well, you guys, fucked up pretty badly in the beginning of the year. It turns out that for us, the previous 2 weeks actually are very low in terms of customer usage. So not a lot of customers using our product Christmas and New Year's Eve. So that's why we get less customer usage, less customer complaints. So the thing here is that 2 points are not a trend. It's really hard to figure out, having only 2 points to compare, what the actual trend is. So besides knowing what to measure, you also need to be able to know how to analyze this one. So you have numbers, 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 but how would you, extract some meaning out of those numbers? Try to instill some superpowers to analyze those numbers. So, pros behavior charts, what are those? So this is a way to analyze continuously incoming data for changing trends. This is not something that I have invented. In fact, it has been around since more than 8 years ago. First was developed in Bell Labs, the guy who put up the telephone and stuff for us to measure resistance of cables. So then they were popularized in Japan, 1950s. Japan was decimated in the Second World War. There were 2 atomic bombs in that country. Very few resources. 80% is a mountainous country, and so there is a very big very big effort by the winners of the war, the United States, for Japan to not fall into the USSR sphere of influence, to be disillusioned by US. So they try to rebuild the country as best as they can. So they shipped out some of the scientists and statisticians and so forth. William Edwards Deming was one of those. So he popularized those, among other things, other techniques, but this one in particular, to Japan. This led to what is known as Japan economic miracle in 1960s. So from 2 atomic bombs in that country, and it rose to the second largest economy in the world after around 15 years. One of those was because the process behavior charts. Then in the later years, they were popularized by Donald J. Wheeler. You can read books on that topic. I'm going to start showing you some graphs now, but and I have some calculations. They're not very complicated, but at the end I have some resources too, if you want to dig deeper, how those look like. The idea is basically to plot the dots and look at the trends. And if you look at Twitter, there is a trend whenever someone posts, this year compared to that year, people reply to plot the dots. So you want to have some long-term long-term analysis. So what you're looking for here is the same number of defects, but plotted for since May this year to May the previous year. And you can see 2019 we have the drop there with a 279% increase. So this looks a little bit better, but still you maybe it's decreasing, but you kind of don't know. So the first thing that you do in analyzing those charts is you get the first 8 points and you calculate the average, or the arithmetic average. So you add those numbers and divide it by the number of points that you have. So take the first 8 and calculate the average. This is how the average looks like. So 49.5 customer complaints. Okay, so that was easy enough. So now comes the hardest part. The next thing that has to be calculated is two of those limits, which is called upper and lower control limits. If some of you have heard about Six Sigma, the graph kind of looks the same, but the meaning is the calculations are different, and why we can talk later on the cocktail, why that is. But what the upper and lower control limits is, they show the variation of the process, and there is 99% chance for the next point, if you have a stable system means all the points are within the upper and lower limits, you have 99% certainty that the next point is again going to be within those limits. So it shows how dispersed the data you have is. All right, so how it's calculated? It's not very complicated. So x is the mean, the average, so 49.5. Then you add 2.66. Multiplying by MR is moving range. So moving range is the difference between the dots that you see here. So in this example, it's 28. So you add all the moving ranges there, get the mean, and that's it. So not going to spend more time on that because you want to go to cocktail party. So this is how the graph looks like. As you can see here, okay, so there are 4 main signals that you have to look in those graphs. The first one is 8 points or more consecutive below or above the line. If this happens here, as you can see there are 8 points below the line, this means that the system has changed. Something happened, and it's not a chance process. This thing has a probability of less than 1% to happen due to chance. So something happened to trigger this one. When something like this happens, you have to recalculate the limit. So this means that it's a significant change. Okay. So this is how the recalculated limits looks like. So looks like we right now we are getting 35 complaints per week. So some improvement has happened here, okay, and in a meaningful way, and we can measure that. All right, so in August 2018, the system has improved. 28% less customer complaints. How do we get that number? Well, we subtract the 49 minus 35. So the two averages, we subtract that, and we know the exact date that the improvement has happened, and with how much exactly. Now, you need to be able, when something like this happens, you need to be able to answer the question, what led to that? What was the cause of this improvement? For us, those were two main reasons. Number one was that we actually, since the beginning of the summer 2018, we started having dedicated teams. So before that, the features that people were working on, the developers, they would rotate to work on different features each iteration. So what would happen is that some people had their own favorite features that they want to work, and whenever it's their turn in the next iteration to work on something else, they would, fumble their fingers and wait for the time to, the rotation to come again to the work on their favorite features. So right now that we have dedicated teams, this means that people can no longer escape. They can work on their favorite stuff, and they know that they have to support this in the long run. All right, so they were more invested in quality. The second thing that happened is we actually invested in the second line support teams. Those are people which are a little bit more technical, so they help filter some of those requests that did not come to the engineering. Now, the 28% increase. Now, first, by the way, when we saw the 28% drop, immediately we saw something is wrong, okay? Something is wrong, maybe customers, maybe there's a glitch in the system, maybe there is a defect and something like that. But it turns out that this drop was not universal for all the teams. Now we have detailed data for 8 or 9 teams that we have, and this was not universal. So some teams got there, but a little bit later. So some teams got a little bit earlier, but as a whole, and those are stats that you probably show to your CTO or CEO, but as a whole, as a company, we get 28% less customer complaints. The second signal that you have to look for is a single point. I have to click it. Is a single point below or above the limits. As you can see here, we have in the Christmas week there, we have 1 point below the limit. Again, this means that there must be some special cause for this reason here. We have very few usage in the Christmas week, so that's why we have 1 point below. So there are 4 such signals that you have to look for. I don't have time to go to the other 2, but I'll give you some literature to read if you want to analyze those. All right, so if you look at the chart again, you see that we have 2 more places where we have 8 or more points above. System has changed, and then I have placed. I mean, the width was not that greater, so I have only 6 points here. But you have to believe me that they're 8. So we have to recalculate. When you recalculate, it kind of looks like that. Now, what happened here is to recalculate 28% improvement, August 2018, and then what actually happened here is it got worse with around 20%. It turns out that, our hypothesis was that this was caused by the influx of more customers. So we have 20% more customers, so we have the same number in terms of percentage increase of customer complaints. And this was our hypothesis. I'll show you why we think we thought about this in the second graph. And then we got some improvement there. The system came back again down, customer complaints. Well, again, our hypothesis was that new customers did not know how to use the system. So they would end up logging a lot of errors and say, hey, this is a defect. And our favorite response is, well, this is a feature. It's not it's not a defect. It's the way the system works. But they didn't know, so we had to beat them with the club on their head, and they learn how to use the system. And this was our hypothesis. That we could improve only with this graph. So 32% less customer complaints later. So overall, if you combine all of our adventures, ups and downs, we got 39% less customer complaints in the last year. So you can, if you're in development and testing, whatever, you can go to your management and say, hey, we had 39% less customer complaints, so we can spend this time on something more useful. For example, writing features, right? So usually the higher you go, people are more interested in such a high granularity charts. All right, the second thing that we measure is our hotfixes. So what is a hotfix? Well, Not all of those customer complaints that you saw in the previous graph end up as hotfixes on production. Some of them are just customer complaints because they don't know how to use, or it's not a valid issue. Customer misread documentation and so forth. So, but certain percentage of those end up as having to have a hotfixes. Could be in the code base, could be in the database, but we have to change something in production. So. Currently, we hotfix around 20% of our customer complaints. I don't know if this is good, bad, because I don't have industry numbers, but I have only one other statistics. The previous company that I worked for, we would fix around 12% of the customer complaints end up. And I can tell you two things. The first one is, if you have high percentage of hotfixes compared to customer complaints, this means that there is some stability issues, that there is some functional failures in your product that it has to be hotfixed. So if it's 80, 90%. If, on the other hand, you have low percentage of hotfixes compared to customer complaints, this means that probably your product is fine, it's working as designed, but maybe customers do not understand how to use it. So it's not obvious, the UX is bad, like they don't know where to click, where to go next. So you may want to pay attention to that. Unfortunately, there are no other industry numbers that I can compare us to say if this is good or bad, but it's just my hunch. All right, so this is how the graph looks like for the hotfixes. To add some significant dates here. So here the customer complaints in August dropped with 28%. Here, also the hotfixes, it took us about a month to drop with 37%. So even here we do 37% less hotfixes. So this is an immediate gain. Again, less customer complaints, less hotfixes. Now, the interesting part is here. If you remember, in the beginning of the year, customer complaints rose with 21%. So customer complaining a lot about stuff. But we did not see any increase in hotfixes. So this proved our hypothesis that the customer complaints were coming from a new customers who did not know how to use the platform that we're providing. So even though we got more complaints, the absolute number of hotfixes is actually remains the same. You can see that all the points are within the upper and lower control limits. And then we got additional improvement here at 32% additional drop. So overall, if you combine, this is for a little bit later. What does this graph look for? Some of you may say, well, you have to put this graph in perspective of how many customers you have. But this graph is useful for forecasting. So right now we do around 6.6 hotfixes a week on average. So this is really good for forecasting because all of the numbers here between 0 and 16, we have 99% certainty that the next week we have between 0 and 16%. And it may not look as very precise, but we were from 0 to 30. So this was our range. So we gradually improve. So you can predict with 99% certainty if you have a stable system that where the next point is going to be. Overall, we have 55% less hotfixes compared to last year. Again, this is a good way to evaluate things like, for example, if you add additional QA guys, okay, did it help? Did it lower the number of hotfixes, and by how much? If you outsource something, did it actually help or got worse? Okay, the third thing that we measure is resolution time. Resolution time is how fast we fix something that the customer complains. And as you notice, all of the metrics that I'm talking about are related to the customer. So it's basically how our customers view us, not internal stuff like code coverage and stuff. So how fast we are resolving hotfixes. Again, we thought that if you have high quality product, maybe it's going to have a faster resolution. There is one peculiarity here. You need to change a little bit the way you calculate that. You need to use median instead of mean. Why? So mean is the arithmetic average, median is the 50 percentile. So 50% of the values are below and 50 are above the point. Maybe a little bit complex right now because it's the end of the day, but a simple example would do so. Imagine Bill Gates walk into a bar, and on average, everyone becomes a millionaire. Okay. So so that's why when you have outliers, you don't use arithmetic average. Okay, so that's why you have to use percentile. So that's why I use median. Another example would be the human height. So there is usually no humans like 3 or five times higher than other humans. So that's why you use average. But when you have outliers, you have to use median. All right, so you plot the median resolution time for how many hotfixes we do each week. We just calculate the median time. This is how the graph looks like. For a long time, we didn't have improvement. And then in the beginning of the year, we got 47% improvement. Now, this graph is fine to see overall improvement trend, but it's not very fine if you want to do some predictions. So the way you do predictions when you have outliers is basically this. All right, so you take the last stable area that you have. So you don't take all the data that you have because the system was different in 2018. 2019 is another system. So you take all the values from the last stable system that you have, and basically you draw a histogram. I assume most of you know. So taking data from the beginning of the year, we could do something like this. So it turns out that there is 57% chance for defects to be fixed within 10 days. So you put all the defects that are fixed within 10 days, you put into that bucket. It turns out that those are 57%. So if a PM walks to you and say, hey, when are we going to do this hotfix? You say, well, there is a 57% chance that we do it in 10 days, right? And if you go further, you can say, well, can't you be more certain? And then you say, well, I'm 74% certain that we're going to do this fix in 20 days, okay? So the further you go, the more certain you are, but obviously, it's a longer time span. All right. So the fourth thing that we measure is rework. And what is the rework? So rework, the way we define that is the degree to which we understand initially the problem. And the rework for us is when we have something to fix, and then we think that we have fixed it, but then the customer comes back and complains, and no, you actually did not fix that. So this means that we did not understand initially what the problem was. Again, this is something related to the customers. That's something that they see. So for us, what we do is we count the number of reopened tickets each week. So we have tickets, and work on a ticket is fixed, and then it could be reopened if there is an issue. Another way to measure that is if you have a regression field in defects, or whenever developers are fixing the defects, they could flag the field and said, well, this was actually a regression. So it used to be working, and then we broke it somehow, we don't know why, and ended up broken in production, customer found it. But we can't just reopen tickets, so for a long time we actually didn't have any improvement on that. So to recap, 39% improvement customer complaints in the beginning of the year. It took us 2.5 months to lag time to do it. So right now from 3.6 reopen a day a week, now we have around 2. So 41% less rework. Again, you can go to the management and say, right now we are doing better, and we are better at initially knowing what the problem is. All right, the fifth thing and the last thing that we measure is internal errors. And some of you may say, well, but those are internal errors, and usually customers are not seeing them. Well, that's not completely true for us, because a lot of times when we have some sort of problem, it manifests somehow in the UI. It may be say, well, for the customer would say, we're experiencing some troubles, try again later. So it's and on the back end is thousands of exceptions streaming. So they see it somehow, but it's not in the raw form that we see. So still is related to customer experience. So again, yeah, those could not be visible by all the customers, but some they usually are. It has to be correlated with product usage, because more customers are using it means more problems. Could be different things depending on if you have a mobile app or web app, or I don't know, back-end, front-end exceptions, whatever. For us, what we do is we measure 5,000 internal server errors, so HTTP requests coming in, and if we reply to 5,000 internal server errors, we'll measure that. So what this graph shows is those are the requests per 1,000 requests. So per mille, this Italian word, means per 1,000. So in the beginning of when we started measuring November last year, so we had around 5 out of 1,000 requests on average would end up with internal server error, right? So we gradually start to improve that. I want to highlight some points here. Those points that go to very high, those are some specific incidents, and I can pinpoint and say this is where Kafka cluster went down, or this is where the storage went, and this is where Amazon did thing, and yada yada yada. But those are specific things, and they're clearly shown on the graph. Another example here is that the gradual improvement actually continued because in the third stable system over there that's highlighted, on average, there is less errors, but the range is very high. The range is very high because of those incidents. But even if we discount those, we see that the trend is continually downwards. Now, I don't know, it's probably going to show here. So it actually right now takes us 7 times, so we actually improved by 7 times the API error. So we went from 5 per 1,000 to 0.7 errors per 1,000 requests. So it's very good. We actually have, on average, each week right now we have less less customer complaints that we have on Christmas week last year that we usually don't get any usage at all. So that's how good it is. Now, by having these superpowers to analyze your graph and your data, and in particular the quality, you should be able to answer those questions, okay? So did we improve? Management asks you about, hey, we hired extra people, did it move the needle? Yes and no. You can, show that and you can answer. By how much exactly? Maybe you have hired 3 people and maybe the improvement was only marginal, only 5%, so maybe the numbers don't add up. So you should be able to answer exactly, 28%, 32, and so forth. Finance guys love those stats. When exactly did it happen? This is really important if you want to figure out what led to the improvement or to things getting worse. Because in our field, in the IT, we're not like doctors where we can have 2 separate sets of people to test some medicine, and one gets the placebo, the other gets the real stuff. So we cannot do 2 teams do different things. One does test-driven development, the other does monitoring and production, and see which is better. So having know exactly where an improvement happened helps you correlate and rewind a little bit back and say, for example, for us this was dedicated teams and second line of support. We actually got so good for related to customer complaints that right now we don't need to hire second person for the online support because we can have the graphs and we can show. We just don't need that person. Anyway, so how confident is our forecast? If you are between the upper and lower control limits, there is 99% certainty that the next point is also going to be there between there. So also you can use a histogram. When the defect is going to be fixed, you can show the histogram with basically the past helps you to predict the future. And the last one is, do we know if a crisis is on its way? So remember the first signal that you see 8 points below or above? If you have 5, 6, 7 points because you draw each point next week, so then something bad is about to happen. So something bad is about to happen, the system will change in a way. So you still have time to steer the ship before you get the 8 points. By the way, one of the reasons why we chose to count weeks instead of months for the data points is that if we need to know if we use months, we need to wait for 8 months to know if the system has improved. Whereas if we use weeks, it's after 8 weeks. All right. So in summary, what some specific takeaways that next week when you go to your office can do, ask yourself this question. If quality was improving or getting worse, what would you observe? Okay, something has to change. So figure out what it is. The second thing is figure out where you should get this data from. For us, those are 3 different sources that we're getting data. So centralized log message, a log service, and then we have Jira for the tickets, and then we have customer complaints is another thing. But figure out where for your system you get the data from. Plot the behavior charts, plot the initial limits, use the first 8 points. And look for signals. Each week at a new point. Has the system changed? Yes, no, recalculate limits, and so forth. A little bit of metrics is this. So the first one is they should not be used for punishment, neither for reward. All of you are smart people, and if your bonus depends on those metrics, you'll try to game it to get your bonus. So don't try to. So think of it as you measure temperature for a sick person. So that would be you don't beat the sick person on the head with a club. Why do you have temperature? Okay. So figure out to use this data to improve, not to punish or reward people. Hawthorne effect is, I don't have time to go into details, but Hawthorne effect basically was It was a factory where they wanted to observe, would the productivity improve if we turn up the temperature? And they turned up the temperature, productivity improved. Then they say, okay, what will happen if we actually lower the temperature in the factory? They lowered the temperature, the productivity also improved. So they have, okay, let's figure out, let's do something with the lighting. So they increased the lighting in the manufacturing, productivity increased. They decreased it, and you know where this is going. So they decreased the lights, and the productivity also improves. The idea here is that if someone knows that you're being observed, you will improve no matter what, because you know that you're observed. So if you want to get some data, so just try at least initially to do it, under camera. Don't say, oh, I'm going to measure you this and this and that. So just try at least the initial graphs to be aware of that. Choose metrics that are hard to game. Code coverage is a very notorious one. Like you can, yeah, some of you are laughing, but setters and getters, you have to test them to get 100% coverage. For example, customer complaints is a thing that we cannot easily game. Okay, so customer either complains or not. Choose something like that. In practice, everything can be gamed, but at least try some that are really hard to game. Also, try to have some complementary metrics that complement each other, like checks and balances. For example, when we measure how much time it takes us to close a hotfix, for example, and if we measure only that and we don't measure the rework, so we may fix it for 1 hour, but then this ticket could be reopened 3 or 4 or 5 times. So you have to, checks and balances. Don't rely only on 1 or 2 metrics. All right, so I have 2 books to recommend, and there's a lot of details there where if you want to dig deeper. The first one is How to Measure Anything by Douglas Hubbard. It's a real book. It's a really good book if you have to measure something that is not tangible, like quality or UX or usability or security. There's a lot of specific examples here. This is a screenshot of the 2nd edition, but there is a 3rd edition going now, so get the latest one. The last one, the second one, is if you want to dig a little bit deeper of why process behavior charts work and what's the math behind them. This is the latest book. Like I told you, this has been around for 8 years. Those kind of stats is not complicated. This is the latest book on the topic by Mark Graban, Measures of Success. In the appendix is really good step by step how you can do calculations, and the easiest ways to start if you have even an Excel spreadsheet would do in the beginning. I think that's all I had. Yeah, so mandatory slide, Falcon.io. That is where we are. We are hiring, so different positions. If you want to come join us, it's going to be fine. And this is the sign that you've been waiting for. This is from actual bar, by the way. So if you, that's the sign to go. I don't have anything else. So thank you for your time. If you have any questions, go ahead. Yep. Thank you. Thank you.